So, hello, Alexander. Hello, nice to have you here.
Hey Arianna, hello everybody at ESTEC Open Day.
Thank you so much for accepting our invitation and for contributing to this very special version of the ESTEC Open Day, which this year is virtual. So thank you so much for being here. I'm super excited. This is the first interview I'm doing to an astronaut. So yeah, I'm really excited about it. And as you may know, the topic for this year Open Day is environment. So you are a geophysicist, right?
That's right.
All right, so I guess in some ways you've been always interested in understanding the environment throughout your career, but I'm curious to know which are the things that amaze you the most.
Yeah, actually, that's a really good point that you mentioned. I just realized when you asked that question that my definition about the environment has actually changed in the course of my years. I think when I grew up, I thought, environment, that's sort of the stuff that's around me. That's what everybody talking about when they mean environment. They say the nature around you, maybe the forests around your city, and this is what counts as environment when you grow up. It's a little bit like your horizon around you. It includes the environment. And then when I studied at university, when I studied geophysics, I did that because I was interested in the world around me, and I realized, hey, the environment, that's not just like the next circle around me, but that's including a lot more, right? It's our entire planet, really. Is our environment. And it's interesting for us because it's important for us because, of course, there's dangers for us because we humans live on this planet, surrounded, embedded in this environment, and we have to understand it to know what's coming for us. That's true for earthquakes. It's true for volcanoes. And in a way, then when I became an astronaut, I realized, wow, well, the environment, it doesn't end just by the surface of the Earth, but everything that's surrounding our planet is also our environment. It's our space environment, and is very relevant for us. If you look at the dinosaurs, they weren't aware of their space environment, and they got like killed by a big asteroid that dropped on the Earth. So we humans, we better understand our environment well. That's why I really like the theme of today. It's a very relevant thing, and we humans should probably think about it more in that it includes everything. It's not just like our next little circle around us, but it's everything that we're in.
It's everything, exactly. And you just mentioned volcanoes, right? I know that you focused on volcanoes in your career. Can you tell us more about that?
Well, volcanoes always fascinated me because it's part of our world. It's part of our Earth that's changing, but it's not changing in geological timescales like in the frame of millions of years. But no, you can go there, you can see an eruption, and the next day this volcano will look different than the previous day, and you feel the power of nature. That is always what fascinated me, but of course also the risk that this poses to people that live in the vicinity of a volcano. I think it's more than 10% of the world's population live close to a volcano, so they are endangered by it potentially. So it's important to understand it, to protect the people around it.
Amazing, thank you. And talking about risk, you have been in a very challenging place in your life. You've been to the International Space Station twice. So the first time was in 2014 for the mission Blue Dot. So what kind of experiments and activities did you perform there?
Yeah, I was very, very lucky to be on the space station twice, indeed. It's a fascinating laboratory. If you look at it, it's worth to take a step back to look at what it actually is. It is humanity's only laboratory that features permanent weightlessness, meaning we can do experiments there without the effect of gravity. There's many effects that are important for us down here, like fundamental physics, chemistry, biology, material sciences, that we need to understand to improve life down here on Earth. But in order to understand them, we need to switch off gravity to really look into the processes involved. And we cannot do that anywhere on Earth. That is the most important thing to understand what the ISS actually is. It's a place that allows us to do something that we cannot do anywhere on Earth. No matter the money, no matter the effort, what we put in, there's no possibility to perform these experiments anywhere on this planet. The only place that humanity has right now is the International Space Station. And that's crazy if you think about it. It's so important for us because with the experiments that we perform up there, we can close gaps in knowledge that we have, that scientists down here on Earth have. In order to advance their part of science, they need to close those gaps, but they cannot do that anywhere down here on Earth. So they design an experiment to be performed on the International Space Station by the astronauts, and then the data comes back down to Earth. They close the gaps in their knowledge fields, and then they can advance their science further down here and do things that are important for us down here on Earth. So in total, the ISS, I've written down the numbers because the numbers actually changing every month. There's more and more. Up to the present day, there were 108 countries involved in experiments on the International Space Station, 4,000 scientists preparing these experiments, and it's about 3,000 experiments since the ISS has started that were performed up there.
It's really a lot.
Yeah, it is. In my 2 expeditions, it was about 600 to 700 in total. And it's things like, well, understanding illnesses, conditions better that humans have down here on Earth. For example, Parkinson's, Alzheimer's, cancer. All these areas of research require, for the understanding of those illnesses, to switch off gravity for a little while to work on them better, to understand them better. For example, Parkinson's and Alzheimer's are serious brain diseases that affect a lot of people worldwide, caused probably by protein crystals growing in the human brain and destroying the brain. In order to understand that, in order to find a cure against it, you need to have those crystals in the lab, to grow in the lab so you can test those medications on it. The problem is on Earth, those crystals do not grow well because gravity disturbs the process. So the idea was, hey, we bring those crystals up to the ISS, we grow them until they're large enough so we can take them back to Earth, to a lab, so scientists can look how to prevent that disease. And that was indeed one of the experiments that we did. Many more we did in the field of material sciences. We have new materials developed in zero gravity experiments in the last many years that eventually led to new alloys that are now in engines or airplane turbines, saving fuel, saving energy, and making them quieter. Also, like a result of the research that we did in zero gravity. Things actually also are related to the environment. Since today's topic is environment, we are also installing sensors, eyes from the ISS that look down on Earth. For example, on my last missions, I installed a sensor called DESIS that looks at multispectral imagery from the Earth, recording its state, recording the state of the environment down on Earth. But it's not only that, it's also space environment that's very relevant. For example, we have the alpha magnetic spectrometer on the ceiling of the ISS, looking out in the universe, like measuring all sorts of radiation and cosmic particles, maybe dark matter, that's raining down on us from the universe that we cannot measure on the surface of the Earth. We really have to go to space. So it's to me, ISS is therefore a fantastic laboratory because it's not only one area of science, but it's all areas of science combined. So we bring back data that is so valuable for humankind that you can say that it's really, ISS is not only the most complex machine that humanity has ever built, but also the most precious one because it cannot be replaced by anything down here.
Exactly, and as I understand, it's a big part in that is played by international cooperation. The ISS, the research that is done on the ISS is possible because there's international cooperation, right?
That's absolutely right. The ISS was built by about 100,000 individuals of 15 different countries. But as you saw before, we have already 108 countries participating in the
Exactly.
science on ISS. So that means every one of these countries would have had something to lose if ISS didn't exist. And that is something that's this shared value between so many countries that makes it so precious. And that also stabilizes international cooperation. That's, by the way, one of the main reasons also politicians are so pro-ISS cooperation, because it's a stabilizing factor in international cooperation. You cannot just like go away and say, oh, I disagree with this, I'll pull out of this project, because you would hurt yourself. So it forces us to come to the table with reason to work together internationally, because we all have something positive to take away from it. That's why it's so precious.
Thank you. I could really feel how we are all part of it. So this is really nice. But coming back for a while to your second mission. So you went again to the International Space Station in 2018. And for that mission, you were the commander of the ISS. So how was that mission different compared to the first one?
Yeah, indeed. It's always very different to go to a second mission to space than the first one, because it's got something to do with like the frontiers, the horizons around us that we step over. When the human goes to space the first time, no one of us can be sure that we're ready to do this, right? You're going, like, you're crossing a boundary that you've never crossed, never even gotten close as a human. So you're getting ready to launch on this rocket, feeling the force of the engines in your back, and then all of a sudden you're in space. How can you prepare for that mentally? It's really hard because you know you're going to do something that nobody can tell you whether you're up for it, whether this is your thing or not. I can only guess, right? So the first mission, you're looking, like, the anticipation to this is great, and also you're a bit anxious about it because, well, you don't know, am I a space person or not? I will find out in the first days. Will this be for me or not? And so this anticipation, of course, for the preparation of the first mission is always a big thing for an astronaut. And then during my first mission, I realized, wow, my personal frontier is not even close to here. This is actually easier than I thought. So yeah, I was thriving up there. I really liked being up there. I realized, wow, I like being in space. I can work there well. I like being with my crewmates, even for half a year in this International Space Station. And then when you're done with your mission, then you know I can do it, right? And then if you get assigned for a second mission, it's much easier to prepare because you don't have anything to be sort of cautious about or afraid of, because you know it's
you are familiar with it
before, and then I can do it. That's right. And but then in addition, I got this added responsibility being the commander of a mission. Of course, it's not only about myself anymore, about how I fit in the space environment, if I can do it. No, it's about me helping my crewmates who have never been to space before. Both of my crewmates that I launched in the Soyuz spaceship, they weren't in space before, so I had to help them, of course, to adapt to this environment, to help them crossing their personal frontier the very first time. So it's a lot of added responsibility. Also on the ground, you have a big team that you have to coordinate. You always have to make sure that everybody in the team, between ground controllers, instructors, the astronaut crew, that there's good communication, that everybody has what they need to train well. There's things like emergency training you have to run as a commander. There's a lot of input that comes from you. You actually run your crew in an emergency. You really have to take decisions yourself because you might not have any connection to the ground. So it's a lot of added responsibility, which I thought it was great, because what was freed up by me being the second time in space, or preparing for the second time, but was freed up by the fact that I didn't have to worry about, can I do this or not? That added capability, I could put in this added task, this added responsibility. And so in total, as our crew, it worked out really well. We flew up there as friends. We came back as friends. That was one of my major goal of being the commander of the space station, was to come back as friends with my crew, to leave the ISS in a state that's at least as good or better as it was before, and to do a lot of science, of course. And we did that. We had quite some challenges to go through during the mission. We had a leak on the space station. We had a launch failure of our follow-up crew, which severely impacted our mission schedule. We really had to stay longer, actually, to make sure ISS is fine. But we nevertheless completed all the science experiments, and so that was a big success. I was very lucky to have such great crewmates who made this possible. And also, of course, all the people down here at ESA, my instructors, my colleagues, engineers, technicians, also the people in the communication department, of course, helping us to carry out the message of what we did up there into the population, have a big part in this success. So thanks to all of you down here, this mission was amazing. A success.
Yeah, Alexander, I can really feel how much you were excited about your mission. And I know that one thing that you really loved was taking pictures of clouds from the ISS. So how is your perception changed after being in space, the perception of the Earth, of course?
Yeah, it's actually, you know, as a geophysicist, you know a lot about Earth, like, you know, the data on how big Earth is or how small, you know, the radius in kilometers down to the third digit, you know how thick the Earth's atmosphere is. But, you know, it's different than seeing it with your own eyes. I think we humans are very visual species. We understand things only really when we see them properly. At least that's what I found. One of my first comments on my first mission, and I only know that because I accidentally recorded it on video when we launched, when I looked out for the window the first time.
Yeah.
It's an inadvertent reaction, and it was, wow, actually it's really round. My first reaction was, wow, I can see this Earth being round all of a sudden. And my second reaction was, I giggled because I had to laugh about myself, that this being my first thought when I looked at the Earth. And then I realized that as a geophysicist, I can never really see my object of study because I'm too close to it. You know, the perspective changes when you go out. So that was the first biggest change, is the perspective on our Earth, on our environment, to realize that it's really, really small. And then I also realized that clouds look beautiful from above, that they're looking really different when you see thousands of them at the same time. I was really fascinated by that. You correctly, I mean, you being in the communications department, you saw all the photos that I sent down from cloud shadows, which was fascinating. But there's also frightening things. You see human impact on the environment from above. You can see entire seas being dried out. The Aral Sea, it's a big inland ocean, basically, that dried out because of humans taking away the water from it. We see deforestation in the Amazon, but also in Europe, everywhere. Big former forests are being cut down. We see fires that are, some of them are started deliberately to cut down forests. We see dried out rivers, we see dams, we see cities. We see a lot of things that humans do that change our environment. For example, glaciers, they get smaller and smaller, and there were indeed changes between glacier sizes between my two missions. So in the second mission, several of these glaciers were significantly smaller than during my first mission. And the worst of all, we do see war from above. We can see humans fighting each other. In one of my missions, I could see rockets being fired from one human to the next in order to kill them. You see that from above. You see bomb flashes. So that was terrifying and very,
Can
very sad.
imagine. Okay, wow, that was both amazing and terrifying to hear from you. Thank you for that. And you were mentioning glaciers, so I would like to bring our audience a little bit from space to another beautiful environment where you have been recently. So you went to Antarctica, right? Can you tell us more about what did you do there?
Yes, actually, you know, it's really a perfect change of topics, because what I did in Antarctica eventually also relates to the environment, thinking about it. It was my 5th Antarctic expedition. I was there 4 times as a geophysicist, and now I was there a 5th time as an astronaut. It was a cooperation, a project, a science project with NASA and ESA, and we were collecting meteorites down there. Basically, it's a long-standing project of Case Western Reserve University and NASA that go down there to Antarctica, because meteorites can be collected really nicely down there. Meteorites, you know, they could have any size, falling from space to Earth every day. Some of them are as small as a grain of sand. Some of them are meter sized. They fall down also here, but we can't find them because there's a lot of rock lying around here. But if we go to Antarctica, which is mostly covered by glaciers and ice, meteorites are actually well preserved at the surface of the ice. And there's some areas where the glaciers actually flush the ice towards the side of the mountain. And if you know those areas, you can just go there and pick them up by the dozens. It's amazing. So
Wow.
we did that. I went there with the team very, very far into the interior of the continent, pretty close to already the South Pole, pretty close to where Scott and Amazon walked by on their way to the South Pole, only a few kilometers away from there, in the glacier field, about 1,000 kilometers away from the next human being, right? Actually, we were more remote away from the next Antarctic base than the ISS. The ISS is about 400 kilometers above the Earth's surface.
Yes.
We were more than 800 to 1,000 kilometers away from the next human being, so very remote, very far away, very cold also, minus 40 Celsius at the peak times. And there we were in a tent for several weeks, more than a month. We lived in tents. And during the day, we drove around with our little snowmobiles and collected meteorites. We collected more than 350 or so that came from outer space, rocks from outer space. Now, why is that important? And that's exactly now the relation to the environment, because meteorites are part of our space environment. So we talked about it before. The dinosaurs were became extinct because of a drop of a meteorite. That's what we think now. And many more occasions, big rocks, like kilometer-sized rocks, drop down to the Earth. And of course, that's very damaging to us down here. So we as a space agency, we need to understand what's happening there. We know that this will happen again. That is very sure that there will be meteorite impacts in the future. So what do we do if there's a big asteroid, many meter-sized asteroid taking course towards Earth? Can we maybe deflect it? Can we save Earth from that impact? In order to do that, we have to understand the material out of which such asteroids are made. Can we put an anchor in? Can we just tug it away? Can we get it out of Earth's harm somehow? In order to do that, we need to exactly understand what materials can be there. So the small meteorites that we find in Antarctica, they are actually fractions, parts of bigger asteroids that they were before. So if we collect them and investigate them, we get a good understanding of what could fall at us in the future. So it's a very relevant thing. But by the way, it's also good training for me, because as you know, international space agencies are preparing to go to the moon, to build the gateway station around the moon, to go back to the surface of the moon, to do science on the moon, to understand it better, to really understand our next neighbor. And to do that will be very similar than the way we do science in Antarctica, because you're in a hostile environment, you have big gloves, you're in a spacesuit, which is very similar to the Antarctic clothing that we wear. So you have a sterile sampling process, because if we pick up the meteorite, we don't want to contaminate it by just touching it. So it's very, very similar. So to me, it's actually a really good training for what might be lying ahead, meaning a European astronaut flying to the moon in the next decade or so. That's quite possible. And so we from the astronaut corps, we're preparing for that. And that is sort of the second big reason why I did this mission to Antarctica.
Fantastic. And what do you think would be the biggest challenges in order to go to another planet or planetary body, so the moon and Mars?
Well, first of all, it's the hostile environment. Back to the word. You know, on the moon, there's no atmosphere, there's radiation that's potentially deadly. There's temperature changes from more than minus 100 degrees. Think about that. To more than plus 100 degrees, so like boiling water, every lunar day. So you have to sort of cope with that environment. There's almost no water there. The dust is like really sharp and caustic. It will destroy most materials that it gets in contact with. So it's a hostile environment that we have to live in. So we need to develop the life support systems, the radiation protection, also ready to land there. We cannot just land on the moon with a parachute because of not being in atmosphere, meaning we have to carry additional fuel to land with a rocket engine, things like that. So it's going to make it quite hard to be there. But on the other hand, the benefit are great. So the moon has probably come out of existence. The interesting thing is, we don't even know it completely yet, where the moon came from. That's sort of our knowledge level of what the moon is. We don't even know where it came from. We think it came from Earth by being knocked out of Earth by a big asteroid, but that's to be confirmed. But in any case, very likely the moon is sort of an open history book about Earth, because of the surface processes on the moon. Without an atmosphere being minimal, we can sort of look at the moon and look at ourselves, look at Earth, how it was many, many billion years ago. So we can learn about ourselves from the moon. The moon is a stepping stone to go to Mars, which will possibly allow us to answer the most important philosophical question that humanity has, in my opinion, which is, well, are we alone out there in the universe? If we go to Mars and we find life there, life that possibly traveled through the universe, or life that came into existence by itself just because the conditions were right. Either way, this would probably mean that the universe is full with life. So imagine this, you and I, everybody here in this audience has a chance within their lifetime to understand whether we are alone in the universe or not. We can understand this by going to Mars and looking for life there. That would be a philosophical bomb if you think about it. The implications of the answer to this question, to me, I get all excited. You can tell that the prospect of answering this question, this is to understand, hey, are we alone out there or not, is in reach. And for that, we have to first go to the moon and then go further to Mars. And that is, it's amazing. We're working on that right now with the space agencies on these projects. And that is, to me, one of the most exciting projects I could think of. And I'm really grateful that I'm part as an astronaut in the development of those missions. And then possibly I can even fly on one of them.
Wow, that was amazing, Alexander. Also because this part of space exploration, so the search for life in the universe, is one of the parts that fascinates me the most. So really fantastic. And I do hope that one day I will be able to talk to you in person, because I know that we've heard that you are coming back to ESTEC to work. So maybe we will get the chance to meet each other. But what are you going to do at ESTEC?
I'm actually already there. I started on 1st of September as a sort of my side job. I continue to be in the astronaut corps. of course, to prepare for missions, to keep my training up, but also I want to make use of my knowledge about like space stations and about this unique experience of having lived in space for about 1 year. So I'm helping currently engineers to develop new experiments, to develop new hardware for the space station. I'm also learning how ESA runs hardware projects from beginning to end. Like I can also see it from an engineer's perspective now, which is great at ESTEC. Of course, there's so many creative people who develop all these hardware items that without which there wouldn't be a space station. So I'm eager to learn this, and at the same time, of course, I can bring in my crew perspective on the future modules that we're developing right now. We're developing the IHAB and the ESPRIT modules for the Gateway, which is the next big international project with all the partners involved. And for that, of course, when you build a space station, it's very important that you have the perspective of somebody who's lived there. You can add small details. You can immediately judge if something works or not. Like we're really working on systems like the life support systems, the crew quarters, the table, the galley, where does the toilet go, and how much room do you need on this module, all those things, where do the handrails go, all that. I'm helping with my colleagues who've been to the space station. I'm helping the engineers to develop that new thing, and that's, to me, it's amazing to be sort of allowed to work with the designers of a new space station, to make sure this is a great module that will fly in a few years' time, and I can sort of give input to that. That's a great privilege together with the engineers, and that's what I'm doing at ESTEC right now. Of course, because of the Corona crisis, I'm in my home office. I can't travel right now, but as soon as it works again, that I can be with the colleagues at ESTEC, I will come back. I already have an apartment there, so it's something that is dear to my heart to not only work remotely but also interact with my colleagues if possible. But right now, of course, we all have to be cautious. Then the COVID numbers go up, so it's better to be very cautious, to go out only with the mask, to stay in home office where we can, to make sure we finally fight this horrible disease, and then get over it, and then get on with our lives afterwards.
Absolutely, we really hope we can make it, but I'm sure we will. And I see you are at home, and I'm curious. There's a very cool picture behind you. Can you tell us more about it?
Yes, that's a launch of a Soyuz. It's a photo of the engines right after a Soyuz rocket takes off, and to me, it's very dear to my heart because I sat on top of such a launch. Of course, I was the only one who didn't see it. Everybody else saw this beautiful rocket climb up into space, but I didn't see it because I was in there. And during the launch, actually, the windows of the spaceship are still covered by the launch shroud, so it's pitch black. You don't see anything until like 2 minutes into the launch, where the shroud is blasted away, and all of a sudden you see the Earth around you. So this is very dear to my heart, and it shows the power of 26 million horsepower. That's what we require to put a rocket into space, and that's it's quite something when you sit on top of that.
I wish I had a similar picture behind me. I need to think about it.
I can send it to you. It's actually on ESA's Flickr page. Everybody can download it.
Oh, great. Thank you for this information. I'm sure the audience will appreciate that. And so I see you have a very long expertise, and you've been on extremely amazing adventures. So I was wondering if there are any takeaways about space and environment that you would like to share with our audience in order to wrap up.
Yeah, that's a very good question, actually. And it's an important thing. One of the things you sort of heard me talking about it before that caught me most, I was unprepared for that, is the perspective change. And I guess that explains also why we humans go to space, and we don't only send machines there. It's important to work together, like at our Directorate Human and Robotic Exploration, we work hand in hand with robots, because this is really the way forward. And one of the things that I noticed is that when we humans go to space, we are touched by the perspective change, by seeing suddenly the Earth with our own eyes in a different way. That does something with us, and that's why it was so important for me to also communicate that, to bring back that perspective down to Earth. If I had one wish free, I would say every human should be able to see Earth from space once, and I think we're going there, but it will be a while. And until that time, my job as an astronaut is to catch that perspective, to combine it with the emotions, with what I felt when I saw that, to wrap it up in a sentence and send it back down with the photo back down to Earth, to have everybody sort of get a feeling of what it is as a human, to look back on the place where everybody came from, the small, tiny little blue marble in the black universe where human life started, where we live since billions of years, and which is our only place. And now comes the actual answer to your question: is what changed? What's my takeaway is this place is really, really, really small and tiny and fragile. This is what every astronaut, every human that goes to space sees when they look back on Earth is, wow, our environment that we think is so huge and so forgiving and has endless resources. Well, it's not. It's a tiny little boat, a tiny little spaceship in our universe that circles around the sun once a year. And in that way, we're all astronauts. We're all sort of part of the crew. And it's our responsibility to watch out that our life support system works. Right? We could destroy it if we wanted. If we don't pay attention, we run out of this and that because we overused it on our Earth. Well, we don't have a planet B. That's very clear from the Earth. So we better use our resources wisely, and we better understand that they're not infinite, by far not infinite. And so this is the biggest takeaway for me, is how precious this place is. Before I became an astronaut, I always thought flying into space must be the most special place. It must be so special to be in space. Well, that's what it is like at the beginning when you look at it. But then you realize, man, the universe is just black and nothing, and there's space everywhere. You can float everywhere, yeah. But there's only a few places that are that are as precious as Earth, that allow us to go out and walk on the beach, to feel the sand and the water between your toes, to feel the wind in your hair if you have some, to hear the leaves rustling in the wind. There's only one place in the universe that we know where we can do that. And what might not seem so special to you because you have it every day will be very special to you if you all of a sudden miss it. And that's my biggest takeaway.
Wow, fantastic. Thank you very, very much, Alexander, for being with us today. It has been a real pleasure for me. And I hope our audience has enjoyed this interview as much as I've done. So thank you so much for that.
Hey, thank you, Arianna. Thanks, everybody, for joining the ESTEC Open Day, despite it being virtual. I'm very much looking forward to possibly next year seeing you all in person again. Thanks for the great job, and I'm looking forward to our next part in the program of the ESTEC Open Day.
Looking forward to it. And now let's go back to our room on Let's Get Digital.